Sure.
Yep. So in any division problem like this, our goal is to multiply by the conjugate of the bottom. So whatever the bottom is, remember to find it. And that goes back to a question on the first page. To find a conjugate, you just change the sign of the imaginary part. So the conjugate of the bottom, it goes from being 3 plus 4i to 3 minus 4i. 3 doesn't change, but the imaginary part does. Is that your understanding so far? Good. And then we're going to do that on the top and the bottom. So 3 minus 4i. And the reason why we do it on the bottom is different than the reason we do it on the top. The reason we do it on the bottom is to make a real number. The reason we do it on the top is so that we don't get stricken down by the math gods, right? So on the bottom, what do we get? Nice, good job. 25. That's just 3 times 3 and 4 times 4. And then the top is just what it is. Like I say there's no shortcut, but that's kind of a lie because eventually you do enough of these and you do start to do them quicker. Um, but this just full on is going to be 15 minus 20i plus 9i minus 12i squared. So that's right. And so that's me just showing as much work as I humanly can. And yes, this just overall becomes plus 12. And then you combine the real parts together. The 15 and the 12 make 27. So we're left with 27. And then all that's left to do at this point is combine the two things in the yellow box. Those are the imaginary parts. And that's negative 11, right? So minus 11i. It is not.
Oh, no.
You have to break it into standard complex form. So right now what it is a standard complex number divided by 25. And what we want to do is the double diagonal division. So you go this way and get 27 25ths. And then go the other way, get minus 11 25ths. And then make sure that your I gets attached to the imaginary, the second term, like that. And do watch out because I haven't written your test for tomorrow yet. It'll be on my to-do list tonight, but um, I like to make these ones I think I threw them together too quick. I like it when these numbers can be reduced. So on the test tomorrow, you might come up against something like, 40 minus 12i divided by like 8. And if that happens, then you reduce. So like 40 and 5 would make, or 40 and 8 would make 5 minus, and then you divide these both by 4 and you'd get like 3 halves by. You with me?
Yeah. Yeah.
Rad. Does that answer your question?
Yeah.
Like I said, I'm open to any questions you guys have. I don't want to bug you, so.
Oh, do you have any of the Sudoku?
I'll get some. I'm going to pause my recording. If you guys have any more questions, that's any of you, just ask and remind me when you ask a question to unpause because I sometimes forget. You do have a question. Right. Okay, go ahead.
We just go real quick over the graph part of my goodness of it.
Yeah, the graph and the modulus are sort of, I'm not going to say they're not related because that would be dumb, but they're not like they're two separate parts. Yeah. So like when I ask you to graph, um, oh, here, I need a new page. So if I ask you to graph a complex number, and I'm really sorry. I know that those graphs are really small, but you guys are young and you have pretty good eyes. So like take for example, like part A. Part A asks you to first graph the complex number 2 minus 8i. So the first thing you're going to do is you're going to go on the real axis to the right 2, and then you're going to go down 8. So you should be graphing that complex number 2, 3, 4, 5, 6, 7, right here. So that's like job one, okay? And I hesitated to put these together. I just thought it logically felt like this should be like one section instead of two. So in this problem, I'm testing you first. Does this kid know how to graph a complex number? Which I'm sure you're fine. And then the second thing is to find the modulus. Now the modulus, FYI, is this length of this yellow line, just for the record, okay? But you don't even have to draw it if you don't want to. Like, I just want to make sure we're all clear. That's what we're about to do. So like you'll see, if you already looked on my answer key, I just slapped the modulus notation onto the complex number and just wrote equals. So To do a modulus, you're going to take each number, ignore the negatives, and square them. What's 2 squared? 4. 8 squared. And you're going to add those together and get 68, and then you're going to put that in a square root sign. If you were to leave it like this, I'd just you'd lose a little points, right? 2 root 17. Does that answer your question?
Yeah. The graphing part of this, I mean.
You want to practice a little bit? I mean, yeah, C is called a pure imaginary, and why it might be confusing to you is because it doesn't have a left or right number. A pure imaginary, so when I ask you to graph negative 7i, I am quite frankly asking you to just go down 7 and put a dot, and there it is, it's done. And what's nice about those is to find the modulus is super cake because it's not a diagonal line. It's vertical, and you can count vertically, right? So we would just slap it on here and say, oh, so the modulus of negative 7i is just 7. And then same for f. F is just a real number. And so if I ask you to graph the complex number 6, I just go to the right 6, which I think is right here. Yeah. And then the modulus of it is 6. All better? Super rad. Anyone else have any questions before I pause her? You want me to make one up or do you want me to do one on the practice quiz? Okay. So I don't know if you noticed or not, you probably were working hard. I just went over the problem C. Were you along or do you want to redo it? Let's do it again. So if anyone's watching the video, they're going to think that I've lost my mind because I'm about to do the same problem again. But heck with those people, right? They don't, what do they know? All right. So when you do division of complex numbers, it's not so much that you're actually performing a division problem. Like I feel like there's closure on some division. Like when you do 20 divided by 4, like you can seal it up and say 5. This one feels less like division and more like we're just kind of messing around. So what winds up happening is, let me give you the big picture. This is an imaginary number, and that's not okay. So what mathematicians agree on is that the bottoms of fractions cannot have imaginary numbers, anything that involves roots. What we always want is for the bottom to be rational. So what you and I are about to do is we're going to essentially rationalize the denominator, but we call it division. Are you ready? Okay. So to rationalize what we do is we take the bottom of the fraction and we multiply it by the conjugate. And do you remember how to find a conjugate? Okay, so conjugates are things like 4 plus 2i and 4 minus 2i are complex conjugates. Or like 5 minus I has a conjugate of 5 plus I. Or, yeah, ringing a bell? Okay, and the thing that you and I learned yesterday is that if you multiply a complex number by its conjugate, something really cool happens, and that is that the answer will be a real number. Bless you. Which, if you're paying attention, you understand is exactly what we're trying to get to happen here. We want the bottom to not be weird and ugly. We want it to just be like 10 or 52 or something nice like that, right? Okay. Bless you again. So are you with me so far? So step one when doing quote unquote division is to do the conjugate of the bottom and multiply that to the top and the bottom because of this. So now when we actually multiply the bottom together, you might remember, and I'm just going to put it really quick and then you and I can talk about why this works. But the answer is 25 because what is 3 times 3? 9. And what is 4 times 4? Don't worry about the negative. And 9 plus 16 is 25. The beauty of conjugates is that all the negatives and stuff will always just naturally work this way 100% of the time. Okay. So what we just did is huge. We got the bottom to be what we wanted. We came here to make the bottom better, and we did it. Now what we have to do is we have to do the top. And to do the top, it's just, again, what a skill that we talked about yesterday. We're going to do the whole four-step process. So like 5 times 3 is 15. 5 times -4i is -20i. 3i times 3 is +9i. And 3i times -4 is -12i squared. And I'll let you get caught up with me. So far, so good. Do you remember what happens at the back of that with the -12i squared? Yep, nailed it. So really what winds up happening is you realize that the 15, this number and this number are both actually real numbers. This one's 15 and this one's actually just +12, which when all said and done makes 27. And then you're going to combine the two in the purple box together because they are both the imaginary components. They're like the like terms, if you will. And what do we get? Right. And the last thing we have to do is convert, uh, like change, I guess convert's the right word. We want our answer to be written in standard complex form. And what that means is we want it to look like that thing, or maybe that thing. So the things I put in the boxes are just a plus bi standard form complex numbers. My answer doesn't look like that because it's like a complex number divided by something. So what we do is we break it and we do like double diagonal division. So the first thing is you divide going in this direction, and whatever you get, reduce if possible, and then just write it down. So that's 27 25ths. And then you have to do it again, but you have to go in the opposite diagonal direction, which is this way. So you just put minus and then 11 25ths. And then all you got to do to seal the deal is just make sure that I gets stuck on the back term like that. And like I was telling Irene, I'm gonna make sure that on tomorrow's test, I hope I remember to make it a little bit more like rewarding at the end. So you might see something like 32 minus 10i divided by, I don't know, like 18. And in this case, when you do your double diagonal division, when you go this way, do you see how you can reduce those by 2? So you'd have like oh, in fact, I'm gonna make this a little bit more exciting. I'm gonna change this to like a 6. So when you go in this direction, you can divide them both by 2 and you would get 16 ninths, right? But when you go this direction, what can you divide by? Yep. So when you divide them both by 6, you get minus like 1/3 of I. So I want to be clear, like each way you go is like its own problem, but that's what the answer should look like. Having said that, you should be able to do like problem F. You're just going to do the conjugate. What's the conjugate of the bottom on F? 4 plus I. Yep, just 4 plus I, and then you'll do your thing. And then on the H, what's the conjugate? Just 2i. You got it. So that's how you do division, is really you just conjugate the bottom, multiply, simplify. Got it? You have any other questions? Okay. Right. Uh-huh. Yeah.